Okay, students, we'll continue with the class. So I'm going to start with continuity and differentiability today. Okay. So we have already discussed about limits. Okay. So certain topics or certain formulas of limits are very important for this chapter. Okay. So before getting into the MCQs, let's just discuss the basic things. When do you say a function is continuous at a point? Simple question. So the chapter name itself is continuity and differentiability. So when do you say a function is continuous? And when do you say a function is differentiable at a point? First, let's discuss about continuous, then we'll go for differentiability. Can anyone tell me f of x? Let's say f is a function. Or if I want to say, when can I say f of x is continuous at x equals a? If I want to tell f of x is continuous at x equal to a, what are the conditions? Make it
when left hand limit is equal to right hand limit.
Left hand limit is equal to right hand limit. Basically, left hand limit is equal to right hand limit. Andre no limit of the function should exist. Andre limit as limit of f of x as x tends to a exists. When does this exist? This is existing only when left hand limit is equal to right hand limit. Last class, I mean, when we were doing limits chapter, we have discussed this. Limit at x tends to a exists only when LHL is equal to RHL. So both LHL and RHL should be equal. Okay, next. Only if this condition is satisfied, we say the function is continuous.
When limit is equal to value of the function.
The second thing is, before what you said, f of a should exist. Limit f of x as x tends to a should also exist. F of a should also exist, and both these things should be equal. That's a third condition. The limit of f of x as x tends to a equals f of a. So more condition. Limit f of x as x tends to a should exist, and the LHL RHL equal agirbeku. F of a kuda nimage value define agirbeku, and iveredu value equal agirbeku. In general, if LHL is equal to RHL and it is equal to f of a, then we say the function is continuous at point a, at x is equal to a. This is the definition for continuous. I repeat, this is very, very important. For many problems, we use this. Okay, especially for finding the value of k. A function is continuous at point x is equal to 2 or x is equal to 3 and find the value of k and questions. For such things, we are going to use. If it is continuous, then LHL will be equal to RHL, which will be equal to f of a. Okay. Now, when do we say a function is differentiable? Continuous gotaito. A function is said to be continuous. One point at the graphically or geometrical meaning, if you are able to draw f of x without lifting your hand, then it is said to be continuous. As simple as that. Okay. This is the mathematical definition. Coming to differentiability. When do you say a function is differentiable? Same
if
thing.
its derivative exists.
Other derivative exists. When does the derivative exist?
At each point in its domain.
That is in general one domain only. If f is differentiable in a domain, if it is differentiable at every point in the domain. Okay. When do you say it is differentiable at a point? And then, for example, let's take an open interval. We always define differentiability in the open interval. Let's say open interval a comma b. Let's take a point C belongs to a comma b. Ivaga at C atra f is differentiable anta heng prove madtira? How do you prove that the function is differentiable at a C?
Same, so left hand differentiable could be equal to right hand differentiable.
Left hand derivative is equal to right hand derivative. That is limit f of x minus f of a by x minus a as x tends to a should exist. Alivari limit f of x as x tends to a exist. Limit f of x minus f of a divided by x minus a as x tends to a should exist. ಇದು exist ಆಗ್ಬೇಕಂದ್ರೆ no, LHT should be equal to RHT. Left hand derivative should be equal to right hand derivative. Then only then this is existing ಅಂತ ಹೇಳ್ತೀವಿ. If this is existing, then we say the function is differentiable at x is equal to c. If it is differentiable in all the points in the interval, then it is said to be differentiable in the domain. Okay. So these things you have to know. So differentiable ಅಂದ್ರೆ ಇದು exist ಆಗ್ಬೇಕು. Continuous ಅಂದ್ರೆ this should exist and should be equal to f of it. This should exist and should be equal to f of it. Okay. These two definitions. Now there are certain functions, okay, which you can directly say they are continuous everywhere. Polynomial functions. Okay. Polynomial functions are always continuous functions. Functions like this. You make a polynomial definition. For example, x square plus 3x plus 2. It's a polynomial of degree 2. Polynomial ಅಂದ್ರೆ ಈ ವೇರಿಯಬಲ್ ಪವರ್ ಯಾವಾಗಲೂ ಪಾಸಿಟಿವ್ ಆಗಿರಬೇಕು. ಇಂಟಿಜರ್ಸ್ positive integer ಆಗಿರಬೇಕು. Okay. So this is a polynomial function. Polynomial function are always continuous function. First point you have to remember this. Polynomial function is always a continuous function because ನಿಮಗೆ ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ನೀವು ಚೆಕ್ ಮಾಡ್ತಾ ಕೂತ್ಕೊಳ್ಳೋದೇನ್ ಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ f of x is equal to x cube plus 3x plus 1 ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ. Okay. 0 x is greater than 1. Sorry, x not equal to 1, x equal to 1. Okay. So usually ನೀವು ಏನ್ ಮಾಡ್ತೀರಾ ಈ ತರ ಫಂಕ್ಷನ್ಸ್ ಕೊಟ್ರೆ f of 1 is 0. Next ಏನ್ ಮಾಡ್ತೀರಾ LHL RHL ಕಂಡುಹಿಡಿತೀರಾ. LHL ವ್ಯಾಲ್ಯೂ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ವ್ಯಾಲ್ಯೂ ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ ಇದರ ವ್ಯಾಲ್ಯೂ ಇಷ್ಟು ನೀವು ಕಂಡುಹಿಡಿಬೇಕು. ಆ ಮೂರು ಈಕ್ವಲ್ ಬಂದ್ರೆ then you say it is equal. Okay, I've just randomly taken an example. Okay, I don't know whether the question is correct or wrong. Randomly I've just taken it. Okay. You can simply directly do it. LHL, RHL ಇವೆಲ್ಲ ಕಂಡುಹಿಡಿಯೋದು ಬೇಕಾಗಿಲ್ಲ. This is a polynomial function. It is continuous everywhere. Therefore, it is continuous. Directly you can do it like that. Okay. So yeah, certain tricks. Polynomial function is always a continuous function. Then sin x, cos x, it is also continuous everywhere. Okay. Then other functions like e power x is also continuous everywhere. Log x is also continuous, but in the interval or in the domain r plus, only for the positive real numbers, because negative is not defined in log. So positive really it is continuous. In r it is continuous, and modulus x is also continuous.